Hello everyone, this video we will talk about definition of light, fiber optic, reflection of light and refraction of light, Snell's law, critical angle, total internal reflection, acceptance angle, and numerical aperture.
Today we are going to talk about propagation of light in fiber optic. And what is light mean to you? Light is rays that travel in straight lines in isotropic and homogeneous medium. When the rays strike on interface, the direction of the rays will change. And if the direction of the ray change in the same medium, then it is reflection, and when it change in different medium, it is called refraction.
And now let me give some brief about the what is optic fiber. Generally, optic fiber have three main parts, which is core, cladding, and jacket. And normally, the light will be propagate inside the core, and the diameter of the cladding will be greater than diameter of core. And there are two modes for light propagate in fiber optic. That is single mode and multi mode. For single mode, the dimension of the core is 9, where the dimension of the cladding is 125. Where for multi mode, the core dimension is 50 and the cladding dimension is 125.
When the rays is passing through the center or axis of the fiber, then it is called meridianal rays. The example of meridianal rays is like this.
This figure shows that they are the reflected and the transmitted ray from the incident ray. Basically, the N1 is more than N2, and Snell's law said that N1 sine theta incident is equal to N2 sine theta transmitted. When the incident angle is increased, the transmitted angle will also increase, where the reflected angle usually is equal to the incidence angle. As the incidence angle increase, it will increase until a critical angle, where the critical angle is same with the incident angles. It will comes to the transmitted angle goes to 90 degrees, and when the incidence angle is more than critical angle, it will occurs effect called total internal reflection. When the incidence angle is less than critical angle, the transmitted ray is reflected and also light is lost. This is the calculation for calculating the critical angle. Sine critical angle is equal to N2 over N1.
Okay, so now we must know how much light can be captured by a core. So first of all, we need to know about the acceptance angle. Acceptance angle is half of the angular aperture of a cone, virtually visualized as a fiber output. Where next we have to know the numerical aperture, which is the light gathering ability of a fiber. To calculate the numerical aperture, we have three different formulas, which is N0, sine theta naught, maximum theta naught, or N1 cos theta incidence, angle of incidence, or N1 square minus N2 square root. If we assume that N0 is equal to N1, we can say that numerical aperture is equal to sine theta maximum acceptance angle. Okay, so as a summary for this video, we know that the refractive index for the core is greater than the refractive index for the cladding. And the other, we must know the Snell's law, which is N1 side incidence angle is equal to N2 side transmitter angle, where when the incident angle is increased, the transmitter angle will also be increased. So when the transmitter angle is equal to 90 degree, the incidence angle will be equal to the critical angle. When the incidence angle is greater than the critical angle, total internal reflection will be occur, and when the incidence angle is less than the critical angle, ray is refracted and light will be lost. The formula that include to calculate the critical angle is sin critical angle is equal to refractive index of cladding over refractive index of the sun. Last but not least is about the numerical aperture. Well, there are three formulas to calculate it. The first one is N0 sin theta N0 sin at the maximum of acceptance angle, and the second one is N1 cos incidence angle, and the third one is the square root of the refractive index of core square minus refractive index of cladding square. Okay, that's the summary for the video.
That's all from us. We are from Group 2B Wednesday Lab.